Hello there, welcome to the engineering mechanics video lectures. So for better understanding, please follow the sequence of the video lectures so that your understanding capabilities will going to be increases. So in this video lectures, we are trying to learn how to determine the moment of inertia for a triangle lamina. So there we can see the triangle lamina is going to be A, B, C is the one of the two-dimensional objects we have taken. The BC is going to be the base we are going to be considering, and the height of this triangle is going to be the h. So what is the first step we have to do here? So the moment of inertia, while you are going to be calculating, first we need to take the elemental strip. Once the elemental strip we are going to be taking, so then we are going to be applying the moment of inertia equations. So I am going to be considering one elemental strip from here. So some distance from the base. So now we are calculating from the base. The thickness of this one I am going to be taking dy because I am going to be taking in the y axis. So dy is going to be the distance, and it is going to be located at a distance of y distance from the base, right? And from the apex, the height of this one is going to be h minus y. So there we can see this height is the y and total height is going to be the h. That's I am taking the h minus y. We know that we are going to be calculating the moment of inertia for this elemental strip. So that I am going to be taking I base, or I xx dash also we can say. I base is equal to the integral y square dA I am going to be considering. So in this case, I want to find out the dA. The dA is going to be your elemental strip area, that is equal to the width of this one I am going to be considering as a L. So that's going to be L into dy. The width is the L and the thickness is going to be the dy. So L into dy. So then what is the value of the L that we are going to be calculating from the similarity of the triangles? So that's going to be similarity of triangle. So that's I am going to be going h by b is equal to h minus y by L. So there we can see this is going to be the one triangle and this is going to be the another triangle. So that's going to be h by b is equal to h minus y by L. Further simplification, L is equal to b by h into h minus y. So I got the L value. Once I got the L value, then I can substitute here. Then I am going to be substituting, and then the elemental strip is going to be varying from base to the top. So that's going to be y is going to be varying from 0 to h. That limits I am going to be considering. So now what I am going to do, I am going to be substituting in this equation. That's going to be I base is equal to integral 0 to h, and y square we are going to be taking as it is. dA is equal to L into dy. So there we can see L into dy is your elemental. So then what is the L value? That is equal to this value I am substituting. So that's going to be I base is equal to integral 0 to h y square. L is equal to b by h minus y into dy. I am going to be simplifying here. The b and h is going to be your constant terminologies. I am going to be taking out. So that is equal to b by h integral 0 to h. So that's going to be y square into h, that I am going to be getting h y square into y minus y cube, I got it, that's going to be dy. Now I am going to be do the integration with respect to 0 to h of this one. So what is the integration here is the y is the variable. So that is equal to b by h, right? So this is going to be h y cube by 3. Here is the y square integration we are going to be getting y cube by 3. So minus y to the power of 4 by 4, and the limits is going to be varying from 0 to h. Once if I am going to be getting, and I am going to be simplifying further. So in this equation I am going to be substituting 0 and h values, that I am going to be taking I base is equal to b by h is going to be the common here. So then h, and here is the y cube into h I am going to be getting here h to the power of 4 by 3 I am going to be getting, and here I am going to be substituting y is going to be here minus h to the power of 4 by 4 I am going to be getting. So this is going to be, so when I am going to be substituting the 0 interval, this total will going to be 0. So I base is equal to h is going to be the common, we can take it and we can cancel out. So that's going to be here b by h. So that's going to be 4h to the power of 4 minus 3h to the 4 by 12 we are going to be taking. So once it is there, so then 4h to the 4 minus 3h to the 4 is going to be the, we have, that's going to be b by h, h to the 4 by 12 we are getting. So then h is going to be cancelled with the 3 times. So finally I am getting I base is equal to bh cube by 12, I got it. So this way we are going to be calculating the moment of inertia with respect to the base. Now we will see with respect to the centroid how we can determine the moment of inertia for the triangle lamina. Now we are trying to find out the moment of inertia of the triangle lamina with respect to the centroid. As we know, what is the centroid? Where the total area is going to be concentrated at that point. So that is going to be existed over here. So that I am going to be taking, so at a distance of h by 3 distance it is going to be there. So already that's we have calculated. That's going to be yc is equal to h by 3. Suppose, and then bc is equal to, that's going to be xc is equal to b by 3. Then similarly we have to find out the area of the triangle. So that is the area of the triangle is equal to half into base into height. So that I am going to be taking half into base is going to be here the b and height is going to be the h. So that's going to be h we have calculated. So then what principle we can see? And initially we have calculated the moment of inertia, that's going to be which is passing to the base. But can you see the centroid is going to be passing away from the base, so at a distance of h by 3. Now we are trying to apply the parallel axis theorem. So what is the parallel axis theorem? That's going to be the centroid is going to be, suppose that I am taking here the centroid CG is equal to, so that I am going to be taking IXX. So I am going to be taking here the base is equal to, that's going to be I base is equal to IXX plus a h square we are going to be taking. In this case I base is going to be which is passing away from the centroid IB. Then IXX is going to be passing through your centroid, and A is going to be area of your triangle and h is going to be the distance between your point of observation to the point of centroid. So that I am going to be taking, we need to be calculated IXX, suppose that's going to be IB minus AH square. So IB is equal to, we have, that's going to be BH cube by 12. So minus area is equal to half B into h. Then h is going to be the height. What is the distance it is located from the base to the centroid? That's going to be h by 3. So that's going to be h by 3 whole square I am going to be considering. So if I am going to be simplifying, BH cube by 12 minus B, this is going to be h square into h, that's going to be h cube, and here is the 3 is there. 3 into 3 is going to be 9, into 2 is going to be 18. So I am going to be taking the LCM, I am going to be simplifying this part. So here the LCM for this one is going to be, so what is the formula we are going to be taking here? That's going to be 12 into 18, the LCM, suppose this is going to be 18 BH cube and minus 12 BH cube, and further simplification 18 minus 12 is going to be the 6. So that's going to be 6 BH cube by 12 into 18. So now I am going to be cancelling this 6 and the 12 is going to be the 2 times. The 2 into 18 is going to be 36. BH cube by 36, I got it. So then, so that is equal to IXX is equal to, the final is going to be BH cube by 36, we got it. So this way, so IXX is equal to BH cube by 36. This is the way we are going to be calculating the moment of inertia. It is representing with respect to this axis, the area is going to be distributing. Suppose if you apply any bending forces, suppose the beam is going to be prepared with the triangular cross section, then you started applying the load on this one. This is the amount of the area is going to be contributing to resist the bending forces. And can you see at the base is going to be BH cube by 12. At the same time, BH cube by 36 is there. So in this case, which area is going to be the more? When the moment of inertia with respect to the base moment, that area is going to be the more. That means the contribution. That means this area also going to be participating in the resistance to the bending moment. So I hope you are able to understand the moment of inertia for a triangle lamina. So how to determine, we have calculated. So now with this one, we are going to be solving the problems in this way. So I hope you are able to understand. So still you feel any difficulty, please put in the comment section so that I can reach out to you. Thank you.